This is an explanation of finding the areas of regular polygons. We did this already for certain types of regular polygons. We were able to, with the right information. Now the formula was half apothem times perimeter, or half times base times height times the number of triangles when we split it, each polygon into two end triangles when n's the number of sides. Without trigonometry, we could do n was 3, 4, or 6. That is an equilateral triangle, a square, or a regular hexagon, because the 3 and 6 involve 30, 60, 90 triangles, and we know those ratios, and the square, the four sides, involved 45, 45, 90. Now, as far as then solving some that are not of those numbers, you do need trigonometry. So here's an example. This is n equals 8, and so we are given that a side length is 6. Always draw in an apothem and a radius, and if there's 8 sides, that means there's 16 of these triangles, 2 per side. And you do 360 over 16 and get this central angle of 22.5, which is not 30, 60, or 45. That's why we need some trig. So we still want to get this side A. This is an opposite, this is an adjacent, so we're going to go with tangent of 22.5 is 3 over A. You can flip these guys. So A is 3 over tan 22.5. It's about 7.24. So now our area is a half times base, which is 3, times height, 7.24. times the number of triangles, which is 16, and whatever that comes out to. Here is a regular pentagon. So in this regular pentagon, you have 5 sides, which means there's 10 of these triangles. And so the central angle, you do 360 for the degrees around, divided by 10, you get 36 degrees. Now, if this side length is 7, we know half of it is 3.5. Again, this is an opposite, this is an adjacent, so we need to use tangent. These guys flip. We get A is 3.5 over tan 36, which is approximately 4.817. So this triangle is half times your base, 3.5, times your height, 4.817, times the number of triangles in the entire pentagon, so times 10. This is a regular hexagon, and we are given a perimeter of 60. Now you could do this without trigonometry, because it's a 30-69 triangle. Just to note that. There's 12 of these triangles, and so 360 over 12 is 30 degrees, which makes this 60. So now if you want to get the apothem, you know it's 5 radical 3 from 30, 60, 90 ratios. However, we can also use trig now. Opposites 5, adjacent is A, so A is 5 over tan 30. Which comes out to, as we can see, well, exactly 5 rad 3. Use a calculator if you want an approximation. So half times the base of 5 times the height of 5 rad 3 times 12 triangles, and yeah, here it is, 30, 60, 90, 5 rad 3. Now for this one, this is a 15-gon, and so rather than drawing the entire 15 sides, all we really care about is just looking at this one triangle. So I didn't draw the whole thing. Perimeter is 180 yards, so there's 15 sides, there's 30 of these triangles. 180 divided by 30 gives you 6 for this side, and 360 divided by 30 gives you 12 for this angle. So that's how I get this side length of the triangle and that central angle of the 15-gon. So now, once again, tangent is opposite over adjacent. So tan 12 is 6 over A. So A is 6 over tan 12. So I do half times my base of 6 times my height of 6 over tan 12 times 30 triangles. And finally, this is a octagon. So again, 8 sides means 16 triangles. 360 over 16 is 22.5. Now we're given the radius, which is the hypotenuse of this triangle. So if we want to get the apothem, it's an adjacent over a hypotenuse. So that's cosine of 22.5 is A over 7.3. Multiply by 7.3 to both sides, and you get this. To get this side, that's an opposite. So opposite over hypotenuse is sine, and multiplied by 7.3. And so now our area is 1/2 times our base, which is all this stuff, times our height, which is all this stuff, times the number of triangles, which is 16. And then, of course, you really need a calculator. This is just a little bit of other trigonometry, advanced trigonometry you can do to simplify it beforehand.